Okay, nice to meet you, everyone. As Dr. Lambert mentioned, I'm the first time to present my presentation for all of you. So I'm really too happy to deliver this lecture today. So before starting this presentation, I'd like to introduce myself. My name is Jae Hong Kim, and originally I'm from South Korea, and I'm specialized cybersecurity field. Over 17 years, I'm working for critical infrastructure cybersecurity area, especially for the power plant and the nuclear plant and gas terminal. So yes, that is my experience and specialty. So today I just picked the topics regarding network fundamentals because this topic is really crucial in the cybersecurity as well as the IT infrastructure field. So I believe the both of cyber and IT, this understanding network fundamental is really important. So I just prepared this presentation today. And especially I'm gonna explain the OSI 7 layers and the IP address. So after this session, I believe and our target for you to understand the how the information and the data communicate between the device to the other device, and what is the IP address. And also we look into the some of the protocols such as HTTP and the SMTP and CISRO. So kind of protocols I'm gonna introduce. And during the session, of course, we're gonna have the Q&A session at the end. But during the session, if you have any questions, just feel free to interrupt me. Then I'm happy to answer. It's kind of interactive session. I like to do that. So yeah, so let me start to the content. So first of all, I'm gonna explain what is the OSI model and TCP/IP model. Let me just let me the recruit. Okay, so sorry, I got some message, pop-up message for the remote access. Okay, so the content is the OSI model and TCP/IP model. So I'm gonna explain what is OSI model and TCP/IP model. What is the common things and what's the difference between them? So I'm gonna explain the comparison between these two models. After that, I'm delving into the OSI 7 layer. So we break down each of the 7 layers, and I'm gonna explain some more details, how data flow from the top to down. After that, we move to the routing, IP address, and the subnet. So we're gonna understand what is the difference between L2 switch and L3 switch, and what is the IP address, and what is the subnet? Why do we need subnet? So that kind of things we will learn. At the end, last but not least, essential network protocols. So the basic protocols like HTTP and the SMTPs and CISRO. So what kind of protocols we have and what they are doing. So we're gonna understand about those things today. Okay, so let's start about OSI model and TCP/IP model. So now you can see the pictures. The left-hand side, here is OSI model, and the right-hand side, TCP/IP model. So OSI stands for Open Systems Interconnections, and TCP/IP stands for Transmission Control Protocol and Internet Protocols. So actually those are describe how the information and data goes to the other device. So they just break down. This is kind of conceptual descriptions of the data flow. So OSI model have 7 layers, as you can see. The application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. So this more granular and theoretical framework designed for teaching and understanding network communication. Whereas TCP/IP model, we have 4 layers: application, transport layer, internet layer, and network access layer. So this is something like a practical implementation used in real-world networking and the foundation of the modern internet. Actually, both are same. The functionality is same. However, the way of description is a bit different. Only the different thing is the number of layers. So let's see the OSI model. In the bottom, we have the physical layer and the data link layer. And this is mapping to network access layer in TCP/IP model. So if someone asks you, oh, can you explain what is TCP/IP network access layer in OSI model? Then you can reply, yes, there is 2 layers break into. One is the data link layer, another one is physical layer. So those are into the network access layer in the TCP/IP. So this is your answer. On the other hand, what is the internet layer in TCP/IP model in OSI? Then your answer will be network layer because they are mapping together as the same color. And transport layer is same. The wording is same. And the TCP/IP model, there is application layer here. But when you see in OSI, they also consist of 3 layers: application, presentation, and the session layer. So actually they are same function, but different number of layers. So if you understand each of layers in OSI model, which is more details and described in here, then you will easily understand what is TCP/IP model as well. So this is the model between OSI and TCP/IP. So today, we're gonna a bit more deep dive each of layers. What is application, presentation, session, transport, network, data link, and physical. So we deep dive. So one of the information for you, if you want to develop your career in the future in the network field, IT field, and the cybersecurity field, then if you get the job interview, this is the most common questions. What is application layer? What is OSI model? What is TCP/IP model, like that? All right, so let's move on to the next. All right, so let's start from top down to bottom. So this is the application layer. Application layer provides network service directly to end user applications. This is where protocols like HTTP, FTP, SMTP, and DNS operate. So let me give you an example. I believe all of you have your mobile phone and mobile device, such as iPhone, either Android Galaxy, either iPad. So you have the mobile device of in your daily life. And for example, you use WhatsApp as a messenger and you chat with your friends. The WhatsApp application belongs to application layer. So this is you want to launch the WhatsApp application, and then you just type your message into that application. That means you are using application layer now. So that is the one of the example. On the other example is the web browsers. So in the daily life, you use the Google browsers, either Microsoft Edge browsers, to search some information, and you open the Google web page. Sometimes you're sending emails from the Gmail, and you're using the Google Drive, and you're using the Google Photo. Those kind of things also belongs to applications. So application is what you are using in the app, like email, web browsers, and the WhatsApp chattings, those kind of things you can understand. Oh, that is belongs to application layer. So this is the layer 7. All right. So let's move to the presentation layer. Presentation layer is belongs to layer 6. And this translates data between application and network format. Now we are living in digital world. So digital means the digital has their own language, which only understand one, either zero. So digital language is 1010110000 like that. So this is the we call the bit 1 and 0. So this digital world is their own digital language between digital device. So what presentation layer is doing? So you type your message into WhatsApp, for example, hello to your friend, HELLO. So this hello is alphabet. So alphabet need to be translated into the digital format and network format, 101010, as you can see these pictures. So what presentation layer is doing? This translates data between application and network formats. So this is the basic functionality of the presentation layer. In addition to that, presentation layer also help your message to be encrypted. For example, you want to type your ID and password into the web browsers, and your password should be encrypted and not shown to anybody. Otherwise, your credential will be compromised. So in this case, presentation layer help you to encrypt your password into the encrypted world so no one can see your password other than you. So all that happened in the presentation layer. And also sometimes you want to upload your files and your photos to sending to someone. The size of the file is too large, and presentation layer also will help you to compress size of your files to smooth sending your file to with your friends. So that is the things happen in presentation layer. All right. So now we are on layer 5. This is session layer. The session layer establishes sessions, manages session, and terminates sessions. Okay, so now we are in the video call, which is Zoom applications. So Zoom application itself belongs to application layer. That is good. We already learned that. And you will connect your credentials into the Zoom applications. So Zoom asks you who you are. That we call authentications. So you put your ID and password, then Zoom allow you to join these meetings. So this is we call sessions. So once you establish the sessions, then even if your Wi-Fi unstable for seconds, this session layer keep your session as stable. So you don't need to notice, you do not notice any unstable things because session layer keep your session looks like unstable. So that is the things in session layer. So they handle authentication, reconnection after interruptions, and synchronization of data exchange. So this is the happening session layer. So now we learn from the application layer, presentation layer, and session layer. This is a mapping to application layer in the TCP/IP model. Let's back to the first diagram here. So now we learn these 3 layers in OSI model. And these, if you describe in TCP/IP model, all of these happen in application layer. So way of description is different, but the fundamental function is same. All right. So now we're going to move to transport layer. Transport layer is quite important things and very important layer because the transport layer break large message into smaller segments before transmission. And in here, in transport layer, there are two very important keyword, which is called here TCP and UDP. So there is TCP protocols and UDP protocols. So one of the keyword in transport layer and the port numbers. So each TCP has port number from 1 to 65535 and UDP also same, the port number from 1 to 65535. So all the application communicate with other applications based on port numbers. So port number act like apartment numbers in a building. It seems like your phone number. Your phone number should be unique, right? In the world, only one number belongs to you. Like your home address. Your home address belongs to you. It should be unique. So seems like the same. The transport layer, they handle the port numbers. They have the port numbers. It's like apartment numbers in the building. So the IP address gets you to the right building, while the port number directs you to the data to the correct apartment applications. So let's see these pictures. The IP address is coming in, and there is two protocol under transport layer. One is TCP, another one is UDP. So from TCP port number 80 going to application 1, if the TCP port number, another port number is going to another application too, like that. So if this transport layer using UDP protocols, then UDP port number 80 going to another applications, the UDP port number, another number is going to another applications. So port number defined which application going to be. So that is the transport layer. So today, if you don't understand what is exactly TCP, what is the exactly UDP, you don't need to worry about that. So today is the fundamental network fundamental sessions. So you just understand, oh, there is TCP and UDP is the keyword. Maybe I have a chance to the next sessions. I will elaborate more about TCP and UDP as a separate sessions. So this is transport layer. And now we are in network layer. So network layer handles routing and forwarding of the data packets across different networks. So for example, you are IT administrator in your company. And you can imagine there are a lot of network in your building. So there is the first floor is network A, and the second floor is network B, etc. There are a lot of network. Just in case, PC1 here in the picture and the PC2 is different network and different subnet network IP address. However, these two between PC1 and 2, they need to communicate each other. So in this case, the network layer, the routing here, this help from PC1, the data packets go through to PC2 destinations. The helping the data flow, these two routers defined and help, they communicate each other. So this is called the networking, routing, forwarding of data packets. So yeah, as an example, when you access to the website, routers examine the destination IP address in each packet and forward it toward the destination, hopping through multiple networks. So a packet from New York to London might pass through more than 15 to 20 routers between them. So this is of the routers, is number of routers more than 15 to 20. There is the hope. So this kind of activities happened in the network layer. So let's remind network layer mapping to TCP IP model is IP layer. So let's back to the diagram here. So now we are running network layer. This is mapping to internet layer in TCP IP. So I want to highlight keyword in this layer is IP, Internet Protocol. This is the primary protocol at this layer, providing logical addressing through IP address, and network layer determine the best path for the data to travel from source to destination across multiple networks. That means the keyword is the IP and the routing in this layer. Okay, so now move to the data link layer. As you can see, this is the network card in your laptops, in your PC, and some your mobile device also have this kind of network device, mostly Wi-Fi adapter. Okay, so data link layer belongs to layer 2 and provides node-to-node data transfer and handles error correction from the physical layer. So it's responsible for packaging raw bits into frames, ensuring reliable transmission between directly connected devices. Okay, so the keyword of data link is the MAC address. You can understand easily. Okay, the data link layer mainly network card, either the Wi-Fi adapters. And each network device, network card have the MAC address. So the MAC address means here in the right-hand side, the consists of 6 bytes. So 1, 2, 3, 4, 5, 6. So each one of them is the byte, 8 bits. So first 3 byte is OUI, so Organization Unique Identifier. So this is for manufacturer. For example, we have Cisco network. They have own OUI. And if you have the NVIDIA network card, graphic card, also they have own OUI. And if you have Broadcom network card, also have unique OUI. So first 3 byte identify which manufacturer is coming from. The other remaining 3 part is NIC, so network interface controller. So each of the device have unique NIC. So first 3 byte, you will come to know which manufacturer is of this network card. And the remaining, the 3 part is unique MAC address, like the same as IP address and your phone number. So in data link layer, within the same network, they're looking for some target device based on the MAC address. For example, in your home, in your office, either in your school, there is computer what you're using. Then if you want to use printer functions, then your PC going to find out the printers based on the MAC address. So this is happening in that data link layer, layer 2. All right. And finally, we came to the bottom. Last but not least, physical layer. So I believe some of you already noticed, oh, physical layer is kind of network cable. Yes, that is correct. So as you can see, this is the Ethernet cable, category 6, category 5, etc. And also the bottom of the picture is the coaxial cable, we call it. So physical layer is the foundation of the network communication, dealing with the actual transmission of raw bits over a physical medium. So this layer defines the hardware specifications, including cable, connectors, voltage levels, and timing of electrical signals. So as an example, Ethernet cable, fiber optic cable, USB connections, and Wi-Fi radio frequencies, etc., etc. So all those things belongs to physical layer. Let me give you an example. For example, this Ethernet cable is mostly within 100 meters. So more than 100 meters is going to be the signal going to be delayed, either signal cannot reach to the target destinations. So in this case, more than 100 meters, then usually we use fiber optic cable. Fiber optic cable is like support long distance of the communications with fast speed. So that is the physical layer. So now you already learned and you also got some detail of the functions of each OSI model layer. And that is great. And this is summary. You are here as sender and you have mobile and you launch WhatsApp and you just type, say hello to your friend. And this is happening application layer. Your message is going to translate it into the digital wording and going to be presentation layer. And your message going to use the WhatsApp app applications using, let's say, port number 500 is going to transport layer. And your friend, you are living in New York, for example, and your friend living in London. Then network layer to find out where is your friend in London, then find out the multiple routers to define the right path. And your Wi-Fi adapters is belongs to data link layer and physical layer. And finally, the message delivered to your friends who live in London as receiver here. So this is conceptual descriptions, what we call it, OSI model. This is we want to express and explain to someone how information and data flow from the device to the other device. That's why we break down into 7 layers, and each of layers have unique functions that we describe here as the OSI model. So yeah, that's the things. All right, so let's move to the next IP addressing. So I see one of the questions from Tom Martins. So good day all. Why did the TCP IP model become the practical standard for the internet in the real world and in Africa to the 3 month of the complete OSI model in the cyber area? Oh, okay. So actually, what I wanted to say, let's back to the what I wanted to say, you don't need to separate and differentiate between OSI model and TCP IP model. Actually, they, as I mentioned, they have same functions. They have same functions, same functionalities. However, the way of descriptions, the way of the expression is a bit different. So the OSI model express the details. They describe the details of the function, each functions break down more and more. But TCP/IP model described in the high level only based on the 4 layers. But as I mentioned, these all are mapping together. So they are same functions. For example, application presentation session belongs to application layer and TCP/IP model. And transport layer same, network same into the internal layer. So every functionality is the same. It's not the different, only different of the expression itself. I hope it will be answered. All right. So now already we learn the OSI model, and now we're gonna learn about IP address. So IP address is Internet's postal system. So IP address is unique numerical identifier assigned to every device connected to the network. So let's assume It's like the same as your phone number again and your street address. So IP address is a logical number we assign to the device. So it can be changed. IP address is not static number. So you configure your own network at your home, either your office, either your school and your class. So this is the example. You have the one laptops, one desktops, and one your phones, and one is your printers. So you want to configure all those network into the one network here. So in this case, you have to assign the IP address. So the 184.19.243.1, 184.19.243.2, 184.19.243.3. So what's different? 1, 2, 3, 4. The last number is different. So that is the IP address for unique assigned to this each device. So this is flexible, as I mentioned. Is we can change anytime because this is the logical numbers we can configure manually into the device. All right, so now we understand the IP address is the unique number assigned to the device, but this is we can configure anytime. So let's a little dig in more about this IP address. One is the IP version 4 format. The most common version used 32 bits, written as 4 decimal number from 0 to 255, separated by periods called dotted decimal notation. Okay, so this is an example. I believe you already may know this 192.168.1.100. So this is the example of the IP address 1, 2, 3, 4 numbers, 4 decimal numbers. This is no more than 255. All right. And right hand side is more described. So this is 32 bits. So it then 4 bytes. So each bytes have 8 bits. So here one number dot 172 dot 224 dot 47. So this is the IP address, the format of version 4. All right. So these have approximately 4.3 billion unique address. It looks a lot, but it's going to running out because we have in the world globally, we have a lot of public IP address need to be assigned. So now this is almost running out. That's why we need another options to sustainable using IP address. So now this is the second options we have, IP version 6. If you see, the newer version uses 128 bits, written as 8 groups of 4 hexadecimal digits separated by colon. Before it was separated by dot, but now separated by colon. And also the number of bits is more increased. It's hexadecimal instead of byte. So this is all 16 bits, 16 bits, 16 bits. So total we have 128 bits. So this is quite extended version. So let's say this is almost unlimited number of the, of course this is limited, but we can consider this as unlimited IP address as a version 6 format. All right, so now is subnetting, dividing networks efficiently. Subnetting is the practice of dividing a large network into smaller, more manageable subnetworks. This improves network performance, enhances security by isolating network segments, and makes more efficient use of IP address. So does anyone see these screenshots in right-hand side? So in your laptops, if you go to network and network properties, you might see this screen when you assign to the IP address. So I just mentioned previously, IP address is not static. Anytime you can change IP address by configurations. So this is the screen when you input type the IP address as per your configuration and requirement. So this is the IP address in the upper level, and in the middle is subnet mask 255.255.255.0. So based on subnet mask configurations, we can configure and segment the network, subnet 1, subnet 2, subnet 3, like that. All right, so let me explain why do we need subnet. So I bring these examples. You are, let's assume you are IT administrator and you need to configure your network in secure manner and also in an efficient manner. And then there are 4 departments under your company. One is HR, sales, engineering, customer support. So your company have 4 departments, and this department, each department is independent. They don't need to communicate with each other department. For example, HR person doesn't need to access sales database, and the salesperson doesn't need to know the engineer's database. Engineers doesn't need to know the customer service. So each of them respectively working independent work. So in this case, we divide the network. Subnet 1 belongs to HR, and subnet 2 belongs to sales. Subnet 4, okay, belongs to engineering, and subnet 3 under customer service. So each of network is now segregated. So they are completely independent and isolated. So why this is good for security? Let me give you an example. So now one of the HR guy, he got hacked. So his laptop compromised, one of the HR guy, and a lot of malware affected in his laptops. And all of a sudden, this malware spread into the company network. So the other colleague in HR person already affected from their colleague. So HR network is totally compromised now. However, we already segregated this network. So the other sales part, engineering part, and the customer support part are in safe because we already divided by subnet. So that is the reason, one of the main reasons why we divide subnet in terms of security, because we don't want to spread any virus, any malware, any ransomware attack into our network. So as much as we can divide our subnet. So that is the one of the reasons. All right. So what is the subnettings? We need to understand what is subnetting, right? So let's see. Class A, B, C. Let me explain about this. Subnetting is the practice of dividing a large network into smaller, more manageable subnetworks. This improves network performance, enhances security by isolating network segments, and makes more efficient use of IP addresses. Basically, in the high level, we can consider Class A, Class B, and Class C. So Class A is the very large organizations. So the range from 1.0.0.0 to 126.0.0.0. So the subnet mask here 255.0.0.0. So for example, This is the subnet mask you can configure 255.0.0.0 like that. So this is the class A in this case. So the other remaining 3 bytes are all host. So number of hosts is like more than 167777214 per network. So this is a really, really large network configurations. And this is the class B. And class B has the range from 1 to 8.0.0.0 up to 191.25.255.0.0. So the subnet mask is 255.255.0.0. That means this is the host numbers, 2 bytes. That means number of hosts are 65,534 per network. Still really large network, right? But we call it this medium size compared to class A. So this is the most common subnet. Maybe you might see a lot of times class C configurations. This is with subnet mask is the 255.255.255.0, and this is like only 254 per network. So this is the most common things designed for small organizations. But even if we call small organization, but still accommodate more than 200 devices into one network. So first 3 octets is the subnet. So only 1 octet is the host. So first 3 is the subnet. So let's see this IP address now. We already configured as subnet class C. So that means this company, each network accommodate up to 205 full per network here. So this is the configurations. So subnetting a little bit difficult concept if you calculate, but don't worry about that. In these lectures, you can understand this is something we have class A, B, C, and you can understand class A is the largest network, class B is the medium size, and class C is the smallest network. So maybe you understand this concept will help you further studies more about these segmentations. Right, so that is the moving data between network we call routing. So anyone does understand what is difference between L2 switch and L3 switch? So L2 switch is using for within the network, in the same network. As you can see, operates at the data link layer. We already learned using MAC address, connects device within the same local network. That means in the same subnet. So we don't need to route because we are all in the same network. In this case, we use L2 switches, which is cheaper than L3 switches. So what is L3 switches? L3 switch operate at the network layer using IP address. We already learned this network layer, right, in OSI model and using IP address. This is also route between different subnet. Oh, so there is different subnet, different network, and sometimes can communicate. How? Using L3 switch. This is we call routing. Routing is the process of selecting path in the network and then allow different network packets go to the other different network packets. So that is the routing. So let's see these pictures. And we have different color. Here is the yellow color. This is a lemon color, green color, pink color, and the purple color here. And each color is the same network. So the yellow is same network, and the lemon color is different, same network. The green color also different, same network within them. So this we have the same, we have the different network here. And in the middle of the network, there is layer 3 switch, L3 switch. So what this function is doing, for example, this green color want to communicate with this yellow color. So this L3 switch defines the configuration from this green color to the yellow color together. So that is the things that happened in the L3 switch configurations. Okay, so the different thing is between L2 and L3 switch. L2 is within the same network. L3 switch allow to different network communicate each other. So we call this routing. So that is the main keyword here. All right, so now we just delve into the couple of protocols, HTTP, Web Transfer Protocols. So hypertext transfer protocols. These protocols use TCP port number 8T and 443. So this is on the transport layer. We already learned it, right? And the foundation of data communication on the World Wide Web. So HTTP defines how messages are formatted and transmitted. So kind of definition of the data format, the message format in the web browsers. So when you have the web surfing, for example, when you open the Google browsers and you type a URL and press enter, then your browser send HTTP formats, the GET format request to the web server, and then get the response with HTML type, CSS type, JavaScript type. So, and then show you the image and the browser data into your site. So this is kind of like the definition, pre-definition together, which kind of data format sending through the web browsers. So that we call HTTP protocols. So in this case, we have two types, HTTP and HTTPS. The difference thing is HTTP doesn't require encryptions. All you message is the plain text, whereas HTTPS provide you encrypted data. So whenever you send text message and you send the URL and informations, that all are encrypted within HTTPS. So we recommend you to use HTTPS instead of HTTP. And the file transfer protocols. So file transfer protocols is using TCP20 and TCP21. So we already learned this on the transport layer, right? So FTP belongs to application layer. However, when it comes to transport layer, the port number 20 and 21, this is their building room. This is the standard protocol for transmitting, like transferring files between the client and server. I believe some of you already have experience for using FileZilla. This is well-known applications in terms of file transfer protocols. So once you download FileZilla, if you use FileZilla now, that means you already use FTP protocols now. And next is SMTP, Simple Mail Transfer Protocols. They're using TCP25, TCP587, TCP465. So this is an internet standard protocol that enables the sending and replying of email messages across the networks, acting as the internet's digital postal service for outbound email. So let's see this diagram. So you send email through SMTP protocols going to your company's mail server and through the internet and the other company's mail server. is going to be, and the final destination of the receiver, they receive another protocols POP3 and IMAP. But you just like you don't need to serious about these protocols. You don't need to understand 100%. These sessions, you understand just the wording. What is the protocol? So now I wanted to emphasize SMTP. This is a very common protocols, mostly used in our daily life when it comes to send email to someone. Then you email deliver to someone using through SMTP protocols. That is the one of the key point. And this is the last but not least, syslog. I want to introduce you to understand syslog. That is really powerful protocols using UDP 4.0.1.5.1.4 TCP 6.5.1.4 port. So syslog sending diagnosis data. Let's imagine you are IT admin and then you have more than 100 L2 switches in your company, and you have more than 20 L3 switches, and you have more than 20 servers and 5 firewalls. You have a lot of babies, more than 100. Then you are the admin, you in charge of all of those devices. How you ensure all those things are healthy, and how you will come to know one of them are fair, one of them are going to be fair. You need to monitor and govern those devices in safe way. So in this case, we're using syslog protocols. So syslog protocols, so each device sending diagnosis information to the syslog server. Then you are here now, you're sitting here, and the syslog server provided the dashboard. So even if no matter what, you have more than 500 devices, 600 devices, all those devices sending data, diagnosis data. So all my memory consumption is more than 80%, and my CPU usage is more than 50%. Oh, my hard disk capacity is more than 90%. Oh, one of my cooling fan is failed. So all those information sending to this centralized server, then you easily come to know, and you will get the alert from those failure. So that is really, really useful protocols. Let's say syslog, transferring event messages from the device. So that is the, we just understand couple of protocols. Actually, there are a lot of protocols in our world, but I just want to introduce you a couple of things as an example. If you understand each of these protocols, it adds value for your the extended knowledge to understand the other protocols easily. So this is my purpose why I added here. All right. So this is the summary today. So today we learn OSI model, and also we compared what is the OSI model and TCP/IP model, and also we understand each layer of the OSI model, and also easy to understand TCP/IP because OSI more layers than TCP/IP, and also we understood the IP address subnetting as a fundamental things. And also we can compare what is the L2 switch and L3 switch and the routing function. And we learn protocols like SMTP, HTTP, FTP, syslog. So I really appreciate for your time today. And now we're going to have some Q&A sessions together. So shall we start for the Q&A
Yeah,
session?
we only have about 5 minutes for questions because at the hour we need to end the class.
Okay.
So we have to make the questions fast and then the answers fast to get through this. Let's go. Ismail, you're up first.
Yeah, thank you, sir. Good morning, sir. Good morning, the presenter. Thank you for the presentation.
Yeah.
Good morning, everyone. Yeah, here is my question. Okay, the question goes this way. By developing a policy framework that organizations should implement to secure their networks at the internet protocol addressing and routing levels, what key elements should be included to address both performance and security concerns?
All right, that's a good question. Okay, as I mentioned, let's back to the presentations to the routings here. So this is the routing. So you ask how we consider in terms of the security as well as the performance. So that's the simple. You need to understand the requirement. For example, this VLAN 5 only need to communicate with VLAN 6. Then you should configure only minimize the communication between 5 and 6 only. But sometimes the people, the configure this VLAN 5 communicate all over the network device. They allow everything because that is easy way. However, this is allow opening a lot of doors. So it depends on configuration. So you want to ensure your security and your configuration and performance. You should understand the requirement of the network configuration. You should configure properly as per the requirement. That is the most basic principles. I hope this will be answer for you.
Perfectly. Thank you, sir. I'm grateful.
All right, thank you.
Okay, now we go to Sun Tum. Go ahead and unmute your microphone.
Well, good afternoon for all my colleagues. Good afternoon, Teacher King. Very wonderful class today. My worries is to ask at the short future time or long time or many times, is it possible to have the charger without the cables, without the cables? The digital charger without the cable. That's the first
Uh,
questions. Are you understand me?
yeah, can you a little bit elaborate more about your question?
I said, my own in this moment because we in all of the engineers computers we have the many evolutions, but until this moment we don't have the digital chargers. We have the cables. Do you understand me? And now
With
I would like to ask you if it's possible for short time or long time to get it at the evolution of the engineers computers. That's the first question. The second question is I like the, how can I say, the when we make the printers, normally in many countries we have the cables, but in other moments, in other countries, in this moment it is a small evolution. Always there's some people in some enterprise they make the printer without the cables, but with the Wi-Fi or with the how can I say with the Wi-Fi or with the connection of the Bluetooth, the
oh,
printers.
all right. Oh, all right. So you mean the Bluetooth connecting printers via Bluetooth?
Yes.
Okay. So there are a lot of the protocols to connect to the printers. Like let's move to this the physical layer. So you mentioned about the Bluetooth and the Zigbee, either many other like a Wi-Fi and the some etc. So there are many protocols, wireless protocols, as well as the physical network cable protocols. So all belongs to physical layer. So in this case, even if you're using the Bluetooth, they should be belongs to the under data link layer and physical layer. So they also have the proper MAC address. The printer already have the MAC address, and your laptops already have the MAC address. So only thing is the communicating with the Bluetooth. So actually that all that are belongs to OSI model under data link layer and the physical layer. So that is the same things. Is this make sense to you?
And my first question, are you understand my first question?
Oh
Charger
yes.
without the cables. Digital
We
charger without the cable.
without carbon. What do you mean carbon? I'm sorry.
The charger of the computer portable to get it without the cable. at the future
Wi-
time? Is it possible or not?
without charger, you mean the battery charger?
The digital charges. Is it possible to get a small evolution of the digital charger without the cables at the future time? Can be long time.
Digit, if possible, can you type your question in the chat? Then I will help to me understand. I'm really sorry about that.
Imagine when it's our computer advance the currents and
Uren.
we wanted to charge this. Normally, we must take the cables to put at the current to computer portal. So now I ask you, so there is in this moment is a main evolution in that areas of the engineering computers. I ask you if along the time is it possible to get this the digital charger without the cables. Do you understand?
Okay. The Dr. Lambert, can you help me to a little bit?
Yeah,
Uh,
is it possible to charge without cables?
Exactly.
you mean the power
Exactly.
charge. Okay, okay. Actually, this is okay. I'm sorry. Now I understand. Now I understand. Okay, actually, this is a bit different perspective. This is another communications. That means the power, the electrical power is like a totally different from the network. So this is like a electrical, the power perspective. So this is, I'm sorry, I can't answer about this because this is not a network topics. So, but I believe the electrical charger, maybe let's search about that. Yeah, I'm sorry, this is limited my area, today's topics.